which is exactly what I've been telling you don't want to do when you're watching a college level lecture, if you have that, okay? You can't get hung up on the fact that your calculator gives you something different than the guy that knows what he's doing tells you. Not that I'm the guy that knows what he's doing, but the guy that you're going to be listening to in a good university knows what he's doing much better than I do, and he's also more careful with his notes, okay? A lot of times he reads from his notes, which if I ever get to the point where I've got to read from my notes, I'll quit, okay? And at my age, that's any day now. Because I do make mistakes. You've seen me make a lot of mistakes, right? There are people who believe you can't be in front of class and be the expert if you make mistakes, okay? I believe if you make too many mistakes, that's true. If you make a few, people see the process of debugging your mistakes, okay? But if I make too many and get to where I have to read off a piece of paper to make sure everything's right, I'm not teaching anymore, okay? At least not at that level. Okay. Okay, now, my point is, we don't want to get hung up on that. I showed you that calculation to reinforce the idea that there's a reason for this, and I don't care what your calculator says, this is right. And if your calculator doesn't say it, you didn't use it right. And it's easy not to use it right. It's easy to leave off a parenthesis or make a sign error. And you got to debug that. Okay? So, that's where this number comes from. The others come from the same thing. And if you use your calculator right, you get the numbers. Now, you make a line here for z equals 0. And your graph is going to come up to that. You just don't know how to spread it out. So you go up to 1 and you make a line that's 60% as long. Okay, to do that, well, maybe you divide this thing in half, and you know it's at least half, but it's 6/10, so it's going to be 1/5 of this distance above here, so you do this, and you say, okay, that's where it's going to be. And now your curve has got to go through here. And then it's got to get back to the asymptote at the x-axis, okay? Because you know what the curve looks like. We've done it several times, we just haven't constructed a good one, okay? Maybe I've drawn a good one because I've drawn a lot of them, but I won't count on it. If I'm going to draw a good one, I'm going to do this, okay? No matter how well I think I can do it, I know I can't do it that well. Now, point 13 is pretty close to 1/7, isn't it? And if you don't know the decimal equivalents of 1 over n for n equals 1 through 10, you should. Just handy to know, it's not that hard to remember them. And you don't want to have to go to Google every time you want to use one. Okay. So we go to 1/7 of this height. Now, I can subdivide this down here, and now I've got a quarter. I can subdivide this, and I've got an eighth, right? Well, an eighth is 0.125. That's pretty close to 0.13. So somewhere between a seventh and an eighth. So if I go about that high, I know that I'm pretty close. Okay? And then I can do the same thing on the other side because you're squaring z, and it doesn't matter if you use a positive or negative of 1 or 2, you're going to get the same thing. So your picture is going to be the same on this side as it is on that side. And now, we can start far enough over here. Like if you go to -3, you get a much smaller number, right? Like you're going to divide 0.13 by 2.718, you've got to get like 0.04, something in there, 0.05 maybe, okay? Which is 1/20th as high as this. If you want to go to -3, you can use that, but it's going to be down pretty close to the axis, and then you're going to draw a nice smooth curve that comes up here. And then because you just don't have the coordination, you're going to do what I do and kind of make it lopsided. You try to correct for that. And you get a very pretty normal curve. Okay? Make sense? Okay, then you can apply this because, big deal. Gee, I'm running out of big deal color here. Do I have any more red chalk here?
Why don't you use that chalk marker, that white chalk marker?
No, I've got to make it red, and I don't have a red yet because the overnight didn't get there overnight. Amazon paid to have it delivered, but you know, it's iffy in this area. I got one of the two, 50-50 chance of getting it overnight, when I usually don't need it overnight, and usually do get it overnight. I'm okay with that. Okay? Okay, so Z is the number of standard deviations from the mean. Okay? The area between two values of Z, that is the area corresponding to an interval of the Z-axis from one value of Z to another, is the probability that your result will be between those values. Now, this is not a rigorous statement because I haven't really defined what I mean by a result. We don't really have this in context, okay? But this is a fairly straightforward idea based on what you know at this point, because this means that if this number is A and this number is B, that probability is this area, which is easily approximated by trapezoidal approximation graph. Which I will take the liberty of abbreviating, because I don't have room to write it out, by TAG. How closely can we approximate this? As closely as we want if we use enough intervals. How do we figure out the altitudes of the trapezoids? Well, if I want to do a trapezoidal approximation for this many intervals, I could calculate this, 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 and this, and this. I could calculate all these graph altitudes from the formula, right? Make sense? No. So I can calculate all these, and if I do this many trapezoids, these trapezoids are going to be really close to the curve, I'm going to get area with an uncertainty of much less than 1%. And that's a big deal. And also, there's no shortcut to doing an approximation, because this area cannot be calculated by the methods of calculus, which is your default way of doing it. Actually, most areas for most functions, except the simple ones, and even simple combinations is simple. This is like an e to the x squared, right? Composite of e to the x with the x squared function. You can't calculate it exactly. Okay? The integration technique doesn't do it. Okay? You do it from 0 to infinity, but you can't do it on any other interval. Okay? And you got to pull all kinds of tricks to do it from 0 to infinity. So you don't need to understand that. Main thing is these concepts, and there's one more thing, one more big deal thing. Total area under the curve is 1. And the middle altitude is 1 over the square root of 2 pi. That's obvious. It's 1 over the square root of 2 pi times 1. That's what you get at 0, so that's how high it is, right? But the main thing is the total area is 1.
So if you get a number, you can calculate the probability that it'll be between like 2 standard deviations by the area?
Yep.
So
Also, the area between here and here is about 0.34. Many of you knew that. And the area between here and here, okay, approximately 0.14. The area from here on, approximately 0.02. How do you know that? You can do trapezoidal approximation graph with 5, 6 intervals, and that's exactly what you get to 2 significant figures, okay? If you want it to more significant figures, you divide it up more. Now, trapezoidal approximation is a linear approximation. You assume it's linear between points. You can also do a quadratic approximation where you kind of do a curve fit for 3 points. And it's much more accurate, okay? And it turns out there's an easy way to calculate that. It's called Simpson's rule, based on trapezoidal and midpoint approximation. But you know, we're not going there. If you understand this, when you take a calculus course and you get to numerical integration, you'll understand it to an extent. Because your default rule is the trapezoidal rule. It's not going to necessarily look like this because people want to use a formula that people can use that don't understand, but it comes down to this, okay? And this is totally equivalent to the silly formula that you get for people that will never understand what it means, okay? Okay, and don't think I'm denigrating people that don't understand what it means, that will never understand what it means. They might have other priorities, and the other priorities might be really valid priorities. They might be concentrating on this area of study and at the expense of this one. And they might be just lazy and worthless, okay? In which case I would tend to denigrate that a little bit, but you don't know why. You don't know what they got up against in their lives. So I'm not putting those people down. I'm just saying they're there, and you know they're there. And you don't know why they're there. You don't know if it's aptitude. You don't know if it's life. You don't know if it's priorities, right? I still say, if they've shown that they're not going to profit from the class, they shouldn't be in the class. Give them a little different class. okay? Because you're gonna confuse them and you're gonna hold back the people who can't understand. That's difficult to do politically. I mean, I know your superintendent, he's a great guy, okay? And most superintendents are, and most principals are. But they're constrained, you know, they gotta make hard decisions. So I'm not putting your schools down or the people that run them. I mean, sometimes you get a bozo in there, okay? And sometimes you get, you know, bad teachers. But for the most part, you got really good people doing their best. So I'm not putting anybody down, I'm putting the system as a whole down, and I am putting the education schools that support this crap down. And the political process, yeah. As I say, you know, democracy is the worst thing you can have except anything else, okay? Not my quote, one of the founders. Okay, so there you have it. And that's your whole basis of statistics, right there. Almost everything you do with statistics can be understood in terms of this picture. And I'll give you some problems that make sense out of that. Okay? Yeah, something, calculate a standard deviation for these flips. Then put that on here and tell me what the probability of getting this many flips is. Okay?
Really?